So as we look at your graph of both the logarithmic and your natural log functions, the biggest thing to remember is, again, those are inverse functions of exponentials. So what I'm going to do here in red is I'm going to write its inverse function. So if I do y equals 10 to the x power, because it's a common log, so it's a base 10, my table will look something like this. So if I plug in 0, my output is 1. If I were to plug in 1, my output is 10. And then if I plug in 2, it gets really, really big. So I'm only going to worry about 2 points right now. I could technically plug in a negative 1, and then that would become 1 over 10, or 1/10. And then to graph my logarithm, because it's an inverse function, it's the same exact thing. I'm just going to flip my table. So I'm going to flip my x and y values. And so along the right-hand or left-hand side, I'm going to have 1/10, I'm going to have 1, and I'm going to have 10, and that'll be -1, 0, and 1. And so when I graph that logarithmic function, I am now going to have 1/10 -1, and so it's going to be about there, 1, 0, and then 10, 1. It's going to look something like that. The only thing to be mindful of is originally with our exponential function, our asymptote is y equals 0. But now, when I think about my logarithmic function, my asymptote is at x equals 0. So again, the thought process here, originally my asymptote is at y equals 0, but now because we flipped our x and y values, our asymptote would be at x equals 0. So if you think about your domain and range, everything is flipped from what we did with the exponential function. So if we look, our domain is from 0 to infinity. Our range is going to be -infinity to +infinity, even though it is growing slowly, it still is growing. It is continuous. It is not symmetric. As far as increasing and decreasing is concerned, it is increasing from 0 to infinity. Again, it's increasing slowly, but it is. It's not bounded. It doesn't have any maxes or mins. The horizontal asymptote, you actually have none, but the vertical asymptote is x equals 0. Your end behaviors. So when you look at this, you've got the limit of f of x as x approaches infinity. So as you look way, way to the right, it's approaching +infinity. Again, it's approaching it slowly. And then you have technically in behavior or a limit at the asymptote. So I'm going to put limit at the asymptote. Is technically not an end behavior because we're not looking at the infinities. But the limit at the asymptote is as your x approaches 0 from the right-hand side, your y is getting infinitely smaller. Okay, so again, this, what I did in red, is technically not an end behavior because it's not happening when x is approaching positive or negative infinity. It is happening at an asymptote. Now, if you look at your natural log, it's a very similar concept. The only difference is your parent function, or excuse me, not your parent function, your original inverse function is e to the x. Because again, natural log has a base of e. So if you think about your xy chart of your inverse function, you've got 0, and if you plug in 0, you get 1. And if you plug in 1, you get 2.7, etc. And you can keep looking further out for that. So let's go ahead and plug in, let's plug in 2. Let's see what happens for 2. So if I do e to the second power, I would get approximately 7.4. But again, our natural log is going to be the inverse of that. So this table, my x's and y's are just flipped. So my y is now my 0, 1, 2. My x's are my 1, 2.7, 7.4. The key again, though, is if I were to plug in a negative value, it's still not going to cross that y-axis. It's just going to get infinitely smaller. So it's going to take the same shape as the logarithmic function that we just did on the left. So I have 1, 0 over 1 up over 2.7, 2.7 up 1 over 7.4. So it would be about there-ish, but up 2. And so when I go to graph this, again, I'm going to have an asymptote at that y-axis. It's just going to look slightly different because it's going to grow quicker than my logarithmic function. My domains and ranges, though, because it's generally the same shape as my logarithmic function, I'm just going to do this. It is literally the same. It's just a matter of how steep it's increasing or how steep how quickly it is increasing. But everything else is exactly the same. So as you guys look at this, the bottom part is just doing some transformations with those pieces. So if we look at this down here, describe the transformation and sketch the graph by hand. So again, my parent function of this is the log of x. So if we want to think all the way from the beginning, my original inverse, something that we can process fairly easy, is y equals 10 to the x. So we can go ahead and set up a table. We have -1 is 1/10, 0 is 1, 1 is 10. That's my original inverse. So my original log, oops, I wanted to do that in blue, sorry. My original log is the same thing, just flipped. So my x and y chart is just flipped. So -1, 0, 1, 1/10, 1, and 10. So now when I graph this, I'm at 1, 0, and I'm at 10, 1. This is my original. This is my original logarithmic, okay? But my graph that I'm looking at in this particular case, this is telling me that it's gone left 2, and this has been vertically stretched by 3, and reflected because it's negative. So what I would recommend is many of you guys would probably benefit from the table of this. So especially on the y chart. Actually, I'm going to do that just on the y. So the y, everything here is being multiplied by -3. So if I look at this, multiply everything by -3. So this is going to become 3, 0, -3. And again, everything has been shifted left 2. So this point, for example, here has gone left 2, and I'm going to leave it alone. 10, 1 is going to be left 2, but instead of up 1, it's going to be down 3. And then keep in mind, my asymptote was originally at the y-axis, but since it's been shifted left also, it's going to look something like this. And so instead of growing as you read left to right, because it's been reflected vertically, it's going to go this direction. And so now this is going to be your new graph based on those transformations. Okay? So again, it's been stretched vertically by a factor of 3, been reflected because of that negative. The whole thing has been shifted left 2, including your asymptote. For this last one, let me go ahead and kind of walk you through from the beginning again. Your original is going to be the exact same as what we just did over here on this side. So we can go all the way back to the inverse if that helps us. So y equals e to the x. When I look at that, my values for my chart are going to be 0, 1. 1 is then going to be 2.7. And then if I plug in a 2, it's going to be 7.4. But again, that's my e. So my natural log has to be the inverse of that. So therefore, the natural log is going to be flipped. So instead, I have 0, 1, and 2 in the y column, 1, 2.7, and 7.4 in the x. So again, I can graph that if I want, or I can go ahead, and this is not how I did the last one. I can do my transformations and do it just in my chart and then graph that. So my negative in front of the x, or attached to the x, is reflected horizontally. Okay, so because again, it's connected to the x, and then this is telling us that it's gone down 2. Notice our asymptote has not shifted left and right. So what I'm going to do right from the start is I'm going to go ahead and put that asymptote right back where we started with it. The down 2 tells us all of my y's are going to go -2. So now, if I do 0 minus 2, 1 minus 2, and 2 minus 2, that's my new y's. And then my x's, notice that negative x is attached. So everything on my x chart is going to be just switched to negatives. And now I can go ahead and graph those 3 points. So I have -1, -2. I have -2.7, -1. And I have 0, or -7.4, 0, and it's going to look something like this. Okay, so I still have the exact same asymptote. So again, what I would recommend, either do it graphically, if that is okay with you as far as the visual piece, or you can do it with your tables. That doesn't make any difference to me. The big key is recognizing your asymptote of x equals 0 in both cases, and being able to shift that to help you give some sort of shape to your graph. All right, obviously, guys, ask questions as they come up. They will come up, but the big connection is making sure that your logarithms are inverse functions of your exponentials. Let me know how I can help. Thanks.